Hi, here we have the number of positive integers less than 50 having exactly two distinct factors other than 1 and itself is how many? Okay. So, we have to figure out a number, let's say n, such that the number of factors of this number will be how many? So, there are two factors other than 1 and itself. So, there are 2 plus 1 is one of the factors and the number itself is one of the factors. So, we have 2 plus 1 total 4 factors. So, we have to figure out all the numbers which are less than 50 which have 4 factors. Now, a number when written in prime factorized form having 4 factors will be of the form either a raised power 1 into b raised power 1 or it will be of the form a cube, right? We know how we calculate number of factors is if we write a number in prime factorized form as a raised power p into b raised power q into c raised power r, then the number of factors is p plus 1 into q plus 1 into r plus 1, right? So if this number of factors has to be 4, there are only two possibilities. Either p is 1, q is 1 and there will be no term for r, as in there will be no third prime number, or the other possibility is that p is 3 and there is no second prime number itself, right? So there are these other two possibilities that we have, a raised power 1 into b raised power 1. So number of factors here will be 1 plus 1 2 into 1 plus 1 2, 2 into 2 4, or the number of factors of this will be 3 plus 1 4, right? So these are the two cases that we have. So let's consider these two cases. So let's start with the first case here, case 1, that n is of the form a raised power 1 into b raised power 1. Now let's see what are the possible values of a and b. Now a and b are prime numbers here. We are talking about prime factorized form, right? So a and b are prime numbers. Now if a is equal to 2, what are the possible values that b can take? The least prime number is 2, right? So we take a2. Then b can be, the number has to be less than 50, right? So b also has to be prime number. So b can be either 3, 5, 7, 11, 13, 17, 19, 23, and then 29 will not be possible because 29 into 2 will become 50. So if a is 2, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities are there if a is 2. What if a is 3? If a is 3, b can be either 5, 7, 11, 13. It cannot be 17 because 3 into 17 is 51. So these are the only 4 possibilities if a is 3. What if a is 5? Then b can be either 7 or it cannot be 11 also. It can only be 7. So only one possibility here. What if a is 7? Now if a is 7, the prime number greater than 7 is now 11. So b cannot be 11 because 11 into 7 will become 77. So there are no other possibilities in this case. So the total number of possibilities in this case is 8 plus 4 plus 1 total 13 possibilities. So from first case we get 13 such numbers, right? Now from second case where n is equal to a cube. So let's see what are the values that a can take. Now a can be either 2, 2 cube is 8, fine. A can be 3, 3 cube is 27, which is also fine. Now a cannot be 5 because 5 cube is 125 greater than 50. So there are two possibilities of a over here. That means there are two possible numbers here. So the total number of numbers which satisfy these two conditions are 13 plus 2, 15. There are 4 factors and the number is less than 50. There are 15 such factors. Hence the answer here is 15. Thank you.